Hello viewers, in today's class we are going to discuss yet another important and conceptual problem in definite integrals, right? And here we have to solve this definite integral where signum function is involved, right? So let us start, and here before proceeding further, let us first take the definition of signum function, right? So here we can take this integral as I, and we know that the signum function of x, that is signum of x, can be defined as plus 1 whenever x is greater than 0, and signum of x is equal to 0 whenever x is equal to 0, and signum of x is equal to minus 1 whenever x is less than 0, right? So this is the definition of signum function which we have studied in functions, right? And here we can have this number line, and here we have 0, and all the points which lies towards the left of 0 are less than 0, and here we have x greater than 0, right? So here in this interval, that is from minus infinity to 0, the signum function takes the value minus 1, and at x equal to 0, this is x is equal to 0, signum of x takes the value 0, right? And in the interval from 0 to infinity, we have signum of x is equal to plus 1 because x is greater than 0, right? So this is all about the definition of signum function. Now let us come to our integral, right? And here we see that the limits of integration are from minus 1 to 1, and here we can take minus 1, and here we can take 1, right? And between minus 1 and 1, this point, that is x is equal to 0, it lies between minus 1 and 1. So as we have just seen in the definition of signum function, so here we have x less than 0, and here we have x greater than 0, right? So in this interval, or in this section of this real number line, this signum of x will take the value minus 1, and here to the right of x equal to 0, signum of x will take the positive value, right? That is plus 1. Okay, so now what we will do, we'll split this integral I as a sum of two integrals, right? So the first one is from minus 1 to 0, because when we have minus 1 to 0 interval, then x is obviously less than 0, and the signum of x will take the value minus 1, right? And when we take the limits from 0 to 1, that is 0 to 1, x is obviously greater than 0, and when x is greater than 0, signum of x will take the positive value, right? That is plus 1. So now I can be written as a sum of two integrals I1 and I2. Now I1 is from minus 1 to 0, and we have x, signum of x, and here we have x square plus 1 dx, and then I2 is from 0 to 1, right? And we have x, signum of x, and here we have x square plus 1 dx, right? So now we have to evaluate these two integrals. Now we can replace this signum of x by minus 1, and this signum of x can be replaced by plus 1, right? So now we have minus 1 to 0, and here we have x times minus 1, and here we have x square plus 1 dx, and here we have 0 to 1 x and plus 1 and x square plus 1 dx, right? Okay, so now these two integrals can further be written as minus 1 to 0, and here we have minus sign, so we can take it outside, and we have x over x square plus 1 dx, and this integral is 0 to 1, and we have x dx over x square plus 1, right? Okay, so now here if we closely inspect these two integrands, we can write them as here we can multiply this x by 2 and divide by 2, and here also we can multiply this x by 2 and divide by 2, right? So we are doing this because the derivative of x square plus 1 is 2x, and here also the derivative of x square plus 1 is 2x, right? So now we have minus half, and the integral of 2x over x square plus 1 is simply a log of x square plus 1, right? And the limits are from minus 1 to 0, right? And here also we have half, and the integral of 2x over x square plus 1 is the log of x square plus 1, and the limits of integration are from 0 to 1. Now here we have used a very important result from integration, that is integral of f prime of x over f of x dx is always equal to a log of f of x, right? So if we have our integrand in this form, that is the numerator is the derivative of denominator, then we can write the direct integration, so log of f of x, right? So here we have x square plus 1 and the derivative is 2x, right? So here f of x is x square plus 1 in this case, and f prime of x is 2x, right? Okay, so now here we can substitute the limits and we'll take the difference. So we have minus half, and here we have log of when we take x is equal to 0, then 0 square plus 1 is simply 1, then minus log of here we have minus 1, x is equal to minus 1, so minus 1 square is 1, 1 plus 1 2, and similarly here we have log of 2 minus log of 1, right? Now we know that log of 1 is simply 0, so we have minus half, here we have 0 minus log 2, and here we have half and log 2, and here log 1 is 0, and this is minus minus plus, so we have half log 2, and here we have half log of 2, right? And half log 2 plus half log 2 is simply log of 2, right? So viewers, the value of this integral involving signum function is equal to the logarithm of 2.